Yeah, it says it in the bottom of my thing. If you go on, just click on the link. It says embedded.com or something. I just went into Google, typed in unit circle, and looked at a million of them. But that one said it was at embedded.com or something, I think.
Are we allowed to have like something like this on our card?
You can draw the unit circle on your card.
Well, I mean, I printed one out.
Pre-made one. Great.
I shrunk it to fit on my card.
Beautiful. Excellent. Do that. Yeah, good idea. Okay, so here we are with inverse trig functions. So that's inverse cosine of root 3 over 2. Okay, so remember, to do these, we've got to remember what an inverse function of any kind does, and then we'll specifically talk about inverse trig functions. So, what does an inverse function do? Let's talk about an inverse toaster. Let's get basic. I'm always doing the toaster talk. So, with a normal toaster, toaster, what do you put into toasters?
Bread.
Things like bread, frozen waffles, things like that. What comes out of toasters? Toast. So you put in bread, you get out toast. So if there was such a thing as an inverse toaster, what would you put into an inverse toaster? You'd put in toast, and it would come back out as bread. You'd put in and get it. It would switch the inputs and the outputs. That's what an inverse function does. Switches inputs and outputs, right? Okay, so let's think about a normal, let me write it right here. So a normal cosine, sine, whatever. What do you put in to cosine? You put in angles, don't you? Like 30 degrees, 60 degrees, 45 degrees, whatever. And what you get out is an answer. Square root of 3 over 2, a half, whatever. So therefore, for an inverse cosine, what you put in, what you get out. So let's think with me logically about this. For an inverse cosine, what are we going to put in? An answer. And what are we going to get out? An angle. You with me? So for inverse trig functions, we're going to put in an answer, get out an angle. We're looking for an angle to come out. So when they ask me, hey, what's the inverse cosine of root 3 over 2? They're saying, hey, that's the answer to some cosine problem. Please tell me the angle. So let's be crystal clear on that. Right? You put angles into normal trig functions, normal cosine. But for inverse cosine, you put in an answer to get out an angle. So I want to know the angle. They're asking me for the angle here, aren't they? So let's go to the unit circle and find it. Let's see if I can find it. Where is my little unit circle? There it is. There's my unit circle. So, with that unit circle, what were we looking for? An answer, root 3 over 2 for cosine. So we're looking for where cosine says root 3 over 2. Remember, cosine, sine, cosine, sine, cosine. Cosine's always the x. There it is, root 3 over 2. There's where that's at 30 degrees, pi over 6. Cosine's root 3 over 2. But what, Jeffrey?
It's also positive in the fourth quadrant as well.
Right here, cosine, sine, right there. There it is at 330, 11 pi over 2. There's two locations, right there and right there. At both places, cosine is square root of 3 over 2. Both places. So they're saying, hey, work backwards. Show me where cosine's root 3 over 2. Give me the angle. Well, we got two answers. We got 30 degrees or 330, pi over 6 or 11 pi over 6. Which one do they want? They only want this one, pi over 6. All they want is the answer, pi over 6.
Is that because you could do minus pi over 6 in the same spot?
You could do a lot of things, couldn't you? Good point. Yeah, this is also called negative pi over 6. It's also called, 360 and you can do two 360s and back up 30, whatever that is, 720 minus 36, 90. There's a million ways to call that other one, isn't there? But wait a minute, hold on. That's a little bit of a sketchy answer. There's other ways to call pi over 6 also. It's 390, 360 plus 30. So they only want one answer. They only want one place. Why? Because they want a one-to-one relationship for inverse functions. What am I talking about? Yeah, so let me do this. Let me give you the official rule. So this is the only answer, pi over 6. And let me give you the story. So for cosine inverse, the answers are only in quadrants 1 and 2. For sine inverse and tangent inverse, the answers are only in quadrants. Anybody remember? 1 and 4. Good job. 1 and 4. Really little tricky thing to remember as you move into calculus. This will come up every now and then. So let me draw. I remember better with a picture. So for these two quadrants, that's for sine inverse and tangent inverse. And these two quadrants are for cosine inverse. We're not going to do inverses of secant or cosecant, cotangent. Just sine, cosine, and tangent. Yeah. Only those two quadrants. So to help you remember, well, I still haven't said why, but I'll get to why in a minute. Well, basically, long story short, they only want one answer. They don't want two answers because they want it to be a one-to-one function. I mean, that is the answer in the end. They only want one answer. They're making there only be one answer, not two, because they want a one-to-one relationship. So notice that all of them use quadrant 1, don't they? See how they all go into quadrant 1? So they all three of them, use quadrant 1 and one other quadrant. Why do they use that other quadrant? That's where they're negative. Do you understand? Remember that all students take calculus? They're all positive in the first. Sine, cosine, tangent, all of them. So that's why they all use the first, because that's where any positive answers will be found. And so again, remember that all students, so what's that mean? That means sine is positive here, which means cosine is negative. So that's why cosine uses the second quadrant, because that's where his negative answers will be found. So if you're doing a cosine inverse and it's positive, first quadrant, cosine inverse negative, second quadrant. Why doesn't sine and tangent use that? Because sine would be positive in that quadrant. So you would have two positive places for sine. You get what I'm saying? They all want one positive location and one negative location to put their positive answers and their negative answers. So that's why they use the fourth, because all students take calculus. Cosine is positive here, which means sine and tangent are both negative. That's why sine inverse and tangent inverse use the fourth quadrant for their negative values. That's what it is. That's what we're doing. Yeah, that's. I'm looking at the clock, wondering if I give a more thorough explanation. I want to at least expose you to it. I don't want to. It's probably worth 2 minutes. Hold me to 2 minutes. Let's see if I can give you the reasons, the deeper reasons why they do all this funny business. So that's what you got to know. Well, yeah, why don't we do some first? How about that? Let's just do some, and then we'll talk about why they do this weird thing. All right, so that's what you got to know. Anytime you're doing a cosine inverse question, the answers are only in quadrants 1 and 2. Ignore the other. That's why when I back over here, say, yeah, it's right here. That's not in quadrant 1 or 2. That's quadrant 4. I ignore it. You with me? There's only going to be one answer. It's either quadrant 1 or quadrant 2 for cosine inverse. Cosine inverse. And for sine and tangent inverse, it's going to be quadrant 1 or 4. Okay, so let's do some actual problems. And I'll talk. So sine inverse root 3 over 2. So you want to look, so we're trying to do, this is number 2. Sine inverse of root 3 over 2. So look at the unit circle. There it is. Question number 2. Sine inverse of root 3 over 2. So you don't need to spend too much time. Once you've found one answer that's in the right quadrant, what two quadrants am I looking for? Well, look, it's positive. If the thing they're giving you is positive, you're always in quadrant 1 for inverse. How about that? Does that make life simple for the beginning? You only have to stress out or be more careful. If they'd made that negative root 3 over 2, then I'd have to go, okay, am I going over the second quadrant Or am I going down to the fourth? I would look in the fourth. But anyway, we're not doing that. If it's positive, it's always the first quadrant only. So just look at the first quadrant. Tell me, where is sine root 3 over 2? Remember, it's cosine sine, cosine sine, cosine sine. Root 3 over 2 right there. Pi over 3. Done. We good? That's the angle. They usually want the radians, almost always. They don't want 60 degrees, I don't think. Let's look back. I think they want the pi over 3. All right, let me get you the unit circle again. So number 3 says cosine inverse of negative a half. Cosine inverse of negative a half. So we're not looking in quadrant 1. We have a negative value. Which quadrant do we look in for cosine? Where do we go to find the negative values for cosine?
1 and 2.
Yeah, 1 and 2. Cosine is 1 and 2, cosine inverse. So we go to quadrant 2 then.
2.3.
So look in quadrant 2 for where the cosine is negative a half. Remember, it's cosine sine, cosine sine, cosine sine. So where is cosine negative a half? Right there, 2 pi over 3. Good? So you're going to need to do this on the exam, the final. This will be on the final, without a calculator. So you have the unit circle on your 3x5 card. You'll find these with the unit circle. 2 pi over 3. That's the angle. Okay. Calculator. Let's hit the buttons. So they want tangent inverse of 11. So let's just hit the buttons. See, how do I know? It says round to the 100, so it's not something that's going to come off the chart. So now, you got to make sure you're in what mode? Yeah, you got to make sure. Go to mode, go down to radian, make sure you're in the radian mode. And I'm getting 1.48. It goes on 1.480136, blah, blah, blah. It's rounded to 2 places, hundredths. Be able to get that on your calculator? 1.48 radians. We good? Where is that? Do you realize that's an angle? Doesn't look like an angle, does it? That's a radian angle. How much is that? Well, all the way around is how much? All the way around is 2 pi. What is pi? 3.14 about. So this is about 6.28. So all the way around is about 6.28 radians. This is, so halfway around is pi, 3.14 radians. So right, I'm just giving you a feel. I just want you to, no, I don't want this to be a number without any feel. So this is about 1.5, isn't it? If this is 3 about, then this is about 1.5, 1.5. So this is just before, this is about right here. I just wanted you to get a feel. It's just before the quarter mark, isn't it? Do you see that? Why don't you have a feel for radians? Remember, radians all the way around is 2 pi, which is about 6. So halfway around is pi, 1.4. So that's half of 3, 1.5. It's just before 1.5, isn't it? It's an angle just a little bit lower than 90 degrees, isn't it? It's like 85 degrees or something. Just want you to have a feel. That's our answer. That okay? Okay, what's tangent inverse of tangent of negative 6 pi over 19?
Negative 6 pi over 2.
Why do you say so?
It's the inverse of itself. It's tangent inverse of a tangent.
Yeah. Boom, boom. Right? They're opposites. Inverse functions cancel each other out. Negative 6 pi over 19. Right? Negative 6 pi over 19.
So if it's the same cosecant or sine, they cancel each other.
Yeah, they're just inverse functions, right? Easy. Yeah, so tangent inverse and tangent are inverse functions. They cancel each other out. If they gave me, first off, they couldn't even do that. If they gave me cotan of tan, say of 6 pi over 19 or negative 6 pi over 19, whatever, they couldn't do that because the tangent 6 pi over 19, remember what goes in as an angle? What comes out as an answer? Well, then you'd be putting an answer into cotan. You can only put angles. That'd be error. You can't even put an answer into cotan. Yeah, they couldn't do that. That'd be different. So, yeah, so I could probably answer it better this way. Good, I see what you're saying. Cotan is upside down of tan. That's different than being inverse. Good, so good question. Does everybody see that? Yeah, this is a point in time where I can actually bring up a bad notation in math. Do you know how when they write tan inverse, what does a -1 power normally mean? Flip it, right? 1 over? Like if I go x to the -1, doesn't that mean 1 over x? It does. So when they put tan to the -1, doesn't that mean 1 over tan, which is the same as cotan? No. They break their rule there. Isn't that bad? It's bad notation on math's part. So let me be clear on what I'm saying they did badly. When they put a -1 power on like a normal letter or anything else, yeah, it means flip it. It means upside down. Reciprocal, upside down. But when they put a -1 on a function, tangent, cotangent, secant, e to the x, f of x, g of x, sine, any function, log, when they put a -1 on any function, it doesn't mean 1 over. It means inverse. Means opposite function. Means inputs and outputs. Switch roles. That's different than upside down. You see this? I'm glad you brought that up. I always forget to clarify that. Does that make sense? It's a bad job on math's part here. So I wish they would have done if it was up to me. I would have said, in order to avoid this problem, I would have said just put a little I for inverse or something. That way you don't confuse it with the -1. But it didn't happen that way, and it's just like anything else. It just was common usage, and people got sloppy. And so after a while, you have to know and be intentional. When a -1 is on a function, so when you have f to the -1, that means inverse function. And what is inverse? Meaning switch inputs and outputs. Bread and toast, right? It's not an upside down toaster. You don't take your toaster and turn it upside down, right? That would be reciprocal. It's inverse. It's a kind of toaster you put in toast and get out bread. It's a reverse toaster. You tracking with me? See the difference between an inverse function and an upside down function, right? So when they put -1 on a normal letter, yeah, it means upside down. But if they put it on a function, it does not mean that. It means inverse tangent, which means you no longer put in angles. You put in answers. Get out angles, right? Okay. Good. Okay. What do you think? Answer? Answer is... Wait, I thought you just told me that these cancel. What's that? Right. What's?
I don't know. It made me put in the -1 here. I don't really understand.
Uh-huh.
So.
Right. So there's actually a little more to the story. I was expecting you to give the same answer, and then I was going to type it into Math Excel all dramatically, and it was going to say no, and I was going to say what's going on here? Yeah, it's not 4π/5. What just happened? I thought we just all happily agreed and reasoned together that a function and its inverse cancel each other out, right? Tangent inverse of tangent, or even if I did f of f inverse of whatever 7, that would just be 7. These guys would cancel, which it would. That's true, right? If you had some inverse function, whatever f is, right? A function and its inverse, they're opposites. So why isn't this working? Why is it not just 4π/5? It worked last time. These just canceled. And if you type that into Math Excel, it is right. It is happy. It is true. That one's right. This one's not. What's the story? It's that whole weird restriction thing that I told you about. It's the fact that tangent only likes values between -π/2 and +π/2. So the answer is, if you're in that zone, if you're in those two quadrants that they like, then yeah, just cancel them out. There's your answer. But if you're outside of that zone, it's going to throw it back into that zone, which will be a different spot. And I know that's tricky, huh? Did you catch that? That's what they're pushing you on these questions. They're saying, do you realize the zone requirements, the specific zone requirements? So in other words, what am I saying? For tangent inverse, what did I say were his zone requirements? from negative pi over 2 to positive pi over 2, right? Let's go back to this one. So, let me get rid of all this other scribbly stuff I did here. This one was okay. This problem was okay because the tangent, again, so whenever you get these kind of questions, here's what you do. When you get this inverse of regular kind of question, basically you're like, hey, I'd like to just cancel them. Can I just cancel them? The answer is yes, you may cancel if, well, how about I say, yes, you may cancel, and the answer ends up, number one, the same if it's in the zone 2 quadrants. Well, I'm not doing this very clearly. Yes, you can cancel. Number one, answer ends up same if sine inverse tangent inverse between negative pi over 2 to positive pi over 2, right? Cosine inverse 0 to pi. Remember the quadrants? So if it's in those zone, yeah, just cancel them. Boom, boom. Answer's the same. That's what this one is. Negative 6 pi over 19. That's between negative pi over 2 and positive pi over 2. Is it? It is. Do you know that? Do you see that? How do I know that? Is negative 6/19 in that zone? Yes. Use your calculator if you want. What is, well, yeah, you know, you need to be able to do this without a calculator. Yeah, you guys know, look at 6/19 pi. Just look at that with me for a minute. That's what would half be? Right, but what's another way? A comparative way, right? I'm asking, is this between negative 6/19 between those? Is it? Question mark? Yes, because pi over 2 would be, what's half of 19? It's almost 10, right? It's 9.5 over 19 pi. Wouldn't that be half? You double 9.5, you get 18, and then the half doubled is one more 19. I just took half of 19. That's a fancy way to write half. 9.5 is half of 19. $9.50 is half of 19 bucks. Right? Yeah. So that's half. So 6/19, and then what's negative a half? Well, negative 9.5 pi over 19. So is 6/19 between negative 9.5 and positive 9.5? Yeah. Negative 6 is between negative 9.5 and positive 9.5. It's between negative pi over 2 and pi over 2. It's in the zone. So we can just cancel these guys out. Everybody see that? Rudy?
Could you also do it like looking at it like where it's negative pi over 2 and pi over 2? Could you just like substitute 180, be negative 90, and then just
Change it to radians?
Yeah.
To degrees? Yeah.
6 times 180 over 90.
Yeah. Won't have a calculator. Part 1. Can you do all that long dividing by hand? Sure. Yeah, is that easier? Yeah, maybe that's easier. How about I do that? So here, let me try that. So we're let me put this one up here again. So back to this one. So we say, is negative 6 pi over 19, is it between negative pi over 2 and positive pi over 2? Yeah, just plug in. Pi's 180, right? So just stick in a 180 like Rudy's saying. So that'd be 6 times 180 over 19 negative. So what's 6 times 180? 0, 48, 1080. And then, so it's 1080 over 19. So can you long divide? So remember how to do all that? What's that go? 5 times? It's like 20 times 5 is 45. 595, 513 left. Bring down the 0. It's a little bit of pain. 7, 6, I think. 6 times 9, 54. 6, 114. So that's 16. So it's 56 and change. So it's negative 56 degrees and a little bit of a remainder. So yeah, is that between negative 90 degrees and positive 90 degrees? Those are 90s, right? Because 180 over 2, 180 over 2. Is 56 negative 56 between negative 90 and positive 90? Yeah. So it's between it's in the fourth quadrant. Everybody see that? Negative 56 degrees is about here. It's not all the way to negative 90, and it's not up to positive 90. It's about right here. So it's in the zone. So tangent inverse, it's in the zone. These just cancel. That's our answer. No big deal. But for the next one, is 4 pi over 5, is that in the zone? Is it? No. 4 pi, put in 180 here. So 4 times 180 over 5. I'll do some math. 4 times 180. 32, 720. Divide by 5. So now you got to go 5 into 720. 5, 1, 5, 22. 4 times 5, 20. 144 degrees. This is 90, positive 90, negative 90. 144, no, it's not in the zone. So then what do? So the answer is not going to be 4 pi over 5. Well, how do you find it then? You got to find the same angle representation that is in the zone. The answer is going to be in the zone. It's going to be first or fourth quadrant. So how do we find that same answer in the zone? What's the same as 4 pi over 5 in the zone? Well, that's not an easy question. These are getting hard, aren't they? So 4 pi over 5 is not in quadrants 1 or 4. Right? So where is 4 pi over 5? Here's pi. 4/5 of a pi is almost to pi. It's about right there. 4 pi over 5. You with me? It's almost 1 whole pi, right? 2 pi is all the way around. 1 pi is halfway around, right? Familiar with all this stuff? So it's almost to pi. So it's somewhere right there. Okay. So what am I going to do? I'm going to make the reference angle. What's this reference angle here? Yeah. It's 1/5 of a pi, isn't it? Right? And I got to make that. Now, which quadrant is it going to go back to? Is it going to go back to the first quadrant or the fourth quadrant? It's going to go back where it has the same. I know there's a lot of complexity here. It's going to go back where it has the same sign answer. Same sign answer. All students take calculus. Right here, sine is positive, but tangent is negative. So it's going to go back to the negative tangent quadrant, not the first. It's going to go back right here to the fourth. It's going to play the same role here. So that's going to be negative pi over 5. Everybody see that? Because this is positive 1/5 pi. Am I going too quick? I'm sorry. There's a lot of detail. I'm totally willing to talk with you longer in office hours. This is the kind of thing where I would not get it in class. The teacher would start doing the Charlie Brown teacher for me. I'd be like, I have no idea what that teacher's talking about. I would just write it all down. But then, because I really cared deeply about my grades and learning stuff, because I knew I can't just not learn stuff in math because it builds, then I would spend hours trying it on my own. I go see the teacher. I get the help I needed. There wasn't these great tutoring programs back when I was in college a couple years ago. So get the help you need. I just don't have time to show every jot and tittle here. This is 4 pi over 5. This is 5 pi over 5. 1 pi, right? So subtract. This is 1 pi over 5. Same thing here, negative pi over 5. Thus the answer is negative pi over 5. It's the same angle in the fourth quadrant. It always will cast it back to one of the two required quadrants. It's really a pain, isn't it? All that restricted stuff. Okay. Tangent inverse of 12. All right, so the question is it just going to be 12? Or do we have to do some fancy casting thing? So how do you know? Let me ask you this. Is 12 an angle or is it an answer? and you can't tell by just saying, well, it doesn't have a pi, it doesn't have a degree, that won't work for you. That could be an angle.
It's an answer because you're getting the inverse of it.
Good, that's the way to calculate it. Based on where it sits, not what it looks like. Right? Because 12 can be an angle. That could be a radian angle. Right? That could be. It's not. Because of where it sits. Remember? What did we say? What do we put into normal tangent? Angles. And we get out answers. What do we put into inverse tangents? Answers. Get out angles. So whatever you put in inverse tangent is an answer. It's not an angle. So this is an answer, isn't it? It's not an angle. If it's being put into tan inverse, it's an answer. So what? Well, that means who cares about those restrictions, negative pi over 2, pi over 2, all that? Those are for angles. Those are for angles. Right? The restrictions are only for angles. They're only for angles. This is not an angle. The answer is 12. Boom, boom. I don't need to worry about whether he's not restricted. He's an answer. 12, yeah. Boom, boom. They cancel 12. Am I losing you completely? Am I making any sense? So if it's an angle, if they're doing the tan inverse, and they put in an angle, see the last one? Look back. See how they reversed order? They had tan inverse here? Look back to this one. See how we had tan on the inside here? How they switched it? That means this is an angle. So when it's an angle, you got to sweat it. You got to worry about whether it's in the zone or not. Right? You got to find out if it's between negative 90 and positive 90 or not. And then if it isn't, like this one wasn't, you got to cast it back to the correct quadrant depending on what angle, what sign it needs and all that complex stuff. But this one, he's just an answer. So yeah, boom, boom. Don't worry about nothing. 12 it is. Good? Making sense? So ask yourself, is that an answer? Pi over 11. Is that an answer or is that an angle? Let that lead you to what you need to do or don't need to do. What do you think about that pi over 11? Is it an answer or is it an angle? Answer. Because it's being put, you put angles in the regular tangent. You put answers in the inverse tangent. That's an answer. It's not an angle. So who cares? Yeah, answer is pi over 11. That's just an answer. So there's no restrictions. They cancel. For sure they cancel. Does that make sense? So that a function and its inverse will cancel if it's an answer you're talking about, not an angle. The only thing we have to worry about is restrictions on angles. It's just pi over 11. One here. Okay. So there we go. So minus 5 cosine inverse. They want me to find the inverse function. How do you find inverse functions? This is a great review of our earlier section on inverse functions. Remember what we do to find inverse functions? Yeah, switch x and y, huh? Switch inputs outputs. So this is y equals minus 5 cosine 4x. So to find an inverse, number one, switch x and y. Number two, solve for y. So I'm going to switch these guys. Bonk, bonk. X goes here. Y goes there. Good first step. Switch x and y. That's what an inverse function means. An inverting of inputs and outputs. X's and y's. So now, step two, solve for y. So y is over here now saying, I want to be alone. Get rid of this minus 5. Get rid of this cosine. Get rid of this 4 so that I can be alone. Solve for me. Get me alone. So can you do that? What's my first step? Yeah, let's start there, huh? At least we can do that. Get that off of there. So bring it over here. So we have x over negative 5 is cosine of 4y. Trying to get y alone. That is the goal. Down here at the bottom, we want y all by itself. All right. Got rid of the negative 5. Now, the next step, it's like peeling an onion, right? From the outer layers on down to the center. Got to get rid of that cosine. How do we get rid of that cosine? We just divide it off of there, right? Cosine on both sides like that. No, that's bad. That means I don't know what's going on. When somebody does that, that means they are really lost. Right? Do you know that's really bad? Because cosine's a function. I see that among my calculus students all the time. No. Cosine is a function that's not times. The fundamental mistake in doing that is they're looking at cosine and these parentheses like they're multiplied. This does not mean times. If it did, yeah, we could divide. But that's not multiplied. That's a function. That 4y is plugged into the toaster. That's what drove me to all the toaster talk. Was when I started teaching calculus and saw people doing that all the time. I thought, oh, they think it's multiplied. They don't understand it's plugged in. I gotta give them something plugged in. Toaster. And I'm just toaster all the time. I'm talking about toaster. So they'll get it that it's plugged in. It's not times. Those parentheses don't mean times. That's like f of 4y is whatever, x, and you're trying to divide by the f. I mean, that's just crazy, right? That's plugged into the function. That's not f times 4y. That's plugged in, right? And that's the case for all functions. Sine, cosine, tangent, log. This is not multiplied. That's plugged in. That's cosine of 4y. 4y is an angle. Okay, well then what do we do? If that's not what we do, I used to all the time. What do we do? Cosine inverse of both sides. Yeah, you come in and you go cosine inverse, and they cancel. And we're out of time. We'll do more of that next time.